slide shows the life history of corals. The corals, they have the basic juveniles and adults, but they also within their life cycle, one important stage is the planktonic larva. Is the stage they disperse. So this slide shows the spawner and the brooder species. So for stony corals, most of the coral species, they are spawners. They release gametes into the water, then fertilized externally. Then the fertilized eggs became the planktonic larvae. The second type of the reproductive mode is the brooders. So the matured eggs fertilize internally in the polyp, then develop into the matured larvae, then release the larvae into the water. The larvae will drift in the water column, and when they are matured and they find a proper habitat, then they settle to the substrate and attach the layer, then became the polyps. In this slide, you see many brown dots, and that is the symbiotic algae in their body. When the polyp forms, then the asexual budding started. So the polyp became from one polyp became two polyps, then two became four polyps, and more polyps forming a colony. And then they deposit the skeleton, so they became stronger. Usually, after 3 to 5 years, they are sexually matured. Then they will release gametes or larvae again. So this is the whole life cycle of corals. And through the reproduction and the coral settlement and recruitment, this is the major force to repopulate the coral population. So if coral population damaged by some events, then this reproduction and recruitment is very important for the recovery. The following slides, I will specially focus on some ecological phenomena in Taiwan, especially in southern Taiwan. I will introduce some interesting research results we find. This slide shows the coral biodiversity map. So you can see Taiwan located in the Western Pacific. Here, with the purple column, it's the coral species diversity ranged from about 300 to 500 species. So it's quite the species diversity is quite high here. And in Taiwan, the best coral reef developed in southern Taiwan. And here, this area right now is the Kenting National Park as a protected area. In southern Taiwan, we have well-developed fringing coral reef along the seashore, and very diverse coral reef community exists here. So, as I introduced before, some area dominated by the stony corals like branching acropora, and some area dominated by the foliaceous corals, and some area the massive or we call encrusting corals. They are very common, and with some strong current area, some area dominated by the soft coral as a carpet, fully covered the substrate, and some area we have a lot of Gorgonian corals there. So looks like under a forest under the sea. One special event is there is a nuclear power plant established in southern Taiwan, and in 1987, the warm water from the nuclear power plant caused the coral bleaching and died. And it's the first time the public pay attention to coral bleaching and the conservation of coral reefs. Another important event is National Museum of Marine Biology and Aquarium established and opened in 2000 here. So this slide shows I want to emphasize the coral biodiversity, and with the bigger fix you can see clearly. So in the middle of the fix maps, you can see the dark red area. It's we call coral triangle with the highest coral species diversity there. So from Philippines, Indonesia, this area with the highest coral species diversity, and Taiwan just in the north of this coral triangle area. So the diversity, coral species diversity ranged more than 300 species. And if you look at it in Great Barrier Reef, their coral species diversity is also this range. So in terms of the coral species diversity, we are abundant as Great Barrier Reef. So in southern Taiwan, for stony corals, we have more than 300 species. It's very high. And for soft coral and Gorgonian corals, the species number are also more than 50 species respectively. So here we have a lot of different coral species, and their abundance is also high. This slide shows the physical environment in Taiwan. So we have a strong monsoon season. In winter, it's northeast monsoon, and in summer, it's southwest monsoon. And we also have typhoon. Every year, about 5 to 6 typhoon hit Taiwan. And sometimes cause a lot of damage. And we located in the path of the warm crucial current. So the warm crucial current bring warm water and a lot of marine organisms from equator to Taiwan. In summer, during the southwest monsoon is strong, the South China Sea surface current will influence the environment here, and also help for the transportation of the marine organisms. We have some research study shows here. We find the reefs in southern Taiwan, if they are damaged, if there is no other negative impact, they may recover quickly. For example, like this green dot shows the Tails Reef in the east side of Nanwan Bay. In 1990, the water is clean and a lot of branching acropora coral exists there. It's a coral reef paradise. But since after that time, the tourism developed quickly. So the coastal development result in a lot of pollution. In 2001, you can see the water is turbid and the corals died, and the area overgrown by sea anemone. So it's very bad for the reefs. But after the sewage treatment started to operate in 2000, after several years, the water getting better, more it's clear and less polluted. So the sea anemone decreased gradually, and the coral skeleton exposed. And it's very exciting to find that the corals, they recovered gradually. And in 2007, some area they have been recovered by stony corals again. But it's a branching multipla, different from the branching acropla, but still very good news for coral recovery. But in 2009, we have a very strong typhoon and caused the reefs damage again. So you can see most of the living branching corals was removed. And this typhoon, its name is Morak. It's a very special event in Taiwan. The rainfall break the record before. Not only a lot of rainfall caused damage under the sea, a lot of reef damaged by the strong wave caused by the typhoon. As I showed in this slide, you can see many these large, massive polites fallen after the typhoon, and some of the corals they are more than 1 meter diameter, so their age is more than 100 years old. So this large, massive corals has been exist there for for 100 years, and after this typhoon, they are fallen and even died. So this typhoon also broke the record to damage the coral reefs. But fortunately, in southern Taiwan, historically, we do not have the outbreak of the corallivorous crown of thorn sea stars. This is very lucky for us because, as I mentioned, this crown of thorns cause a lot of damage in different coral reefs in the world. The reason it not outbreak here may be related to the strong water exchange in southern Taiwan. So their offspring will not survive a lot here. And we also have very few coral disease here. The black band or coral tumor did exist in Kenting Coral Reef, but the frequency is very low. So we are very lucky here. The most interesting and I think is the most important phenomena is we have this internal tide or wave induced upwelling. As you may know, the ocean warming right now is the largest threat for the survival of coral reefs. But upwelling, they can bring the deep water into the shallow area, so they can cool down the warm water, so corals they can survive. Another important factor related to upwelling is the upwelling water. They are more nutrient from the deep sea, and this nutritious water can provide more food for corals, so they are more resistant to the environmental change. So some right now this upwelling influenced reefs they was considered as the possible refuge for coral reefs under the impact of global warming. This slide shows between Taiwan and the Philippines in this Luzon Strait, the internal wave generated in this area resulted from a very complex physical interaction. But you can see from the satellite image, the internal wave generated on the sea surface. So it's very strong and regularly occurred. And in Kenting National Park, in the Nanwan Bay, as this green dot shows there, this area influenced by this upwelling, and on the right side of it, it shows the temperature data. So the temperature fluctuation occurred frequently, caused by the upwelling. Another interesting ecological character is in the north of South China Sea, where is the Dongsha Atoll located. This area, the outer reef, the outer atoll, also influenced by the internal wave-induced upwelling. So this figure shows the temperature fluctuation caused by upwelling. As you can see from the figures, the temperature can drop from about 29 degrees C to about 21 degrees C within a short time. And it occurred frequently, so caused this high frequency fluctuation of temperature. And we are very lucky this Nanwan Bay in Kenting National Park and also the Dongsha Atoll. Right now it's the Dongsha Marine National Park. They are protected, so they can act as the network of marine protected area to help for the sustainable development of coral reefs. This slide shows the Hobihu Reefs. So it's located in the western side of Nanwan Bay. This Nanwan Bay, as I showed in the eastern side, the Taos area, it's influenced by typhoon and the human-made pollution. But in the western side, it protected from the typhoon because the topography, and also the pollution certainly influenced this area. And this area was established as a marine protected area. Right now, the coral reefs still remain very healthy status. So you can see many large branches coral patch, and more fish recovered in this area. Another special combination of environmental condition is we have a nuclear power plant established here. It's also located in the western side of Nanwan Bay, just next by Hobihu area. Before the thermal outflow of the power plant, the warm water caused the small bay coral bleaching and died. But interestingly, about five years ago, the corals became recovered quickly. Right now, there are a lot of corals exist in this area. So call in Chinese we call 出水口. Most of the Taiwanese people, they know this area because the coral bleaching event is raised the public awareness of coral reef conservation. But right now, this 出水口, the outlet of the power plant area, became the most famous diving site for tourism. So you can see a lot of corals and fishes exist there. And this area also protected from the monsoon. So the water condition usually is very good for snorkeling and scuba diving. On the right side, you can see the temperature data. So the outlet seawater temperature, as shown in the black line, is usually about 2 degrees C, higher than the background seawater temperature. This 2 degrees C warmer temperature it resulted from the thermal outflow of the nuclear power plant. And on the lower part of the shows the detail of the temperature variation. So you can see the difference between black line and the red line is caused by the thermal outflow area, thermal outflow warm water, and the temperature drop is caused by the internal tide induced upwelling. So this temperature drop occurred regularly. So this is a spatial environmental condition for coral reef study, because the thermal outflow act as an artificially created warming environment. And right now some corals has been acclimatized to this warmer temperature. So this is very interesting for scientists to study how coral acclimatized to the ocean warming. Another important phenomena is in the inlet of the power plant, because this water breaker protect the coral from the influence of the typhoon, and this inlet area fishermen they cannot go into this area, so it also acts as a marine protected area, and the coral reefs developed there is also very good. This slide shows some monitoring data. So as you can see, in the thermal outflow area in 2007, the coral coverage is about 45%. It's very high compared to other localities in the world. But in 2007, as shown in the temperature figure, it's an abnormally warm event in Western Pacific. So the monthly mean seawater temperature about 2 degrees C higher than before, and caused the coral bleaching event occurred. So the coral cover dropped to about 25%, resulted from coral bleaching and mortality. But interestingly, the coral recovered very quick. In 2009, this two sites, many of the coral has been recovered. So this is also show the reefs in southern Taiwan, they recovered quickly. In the inlet of the power plant, it provides a spatial environment for we to establish this real-time underwater monitoring. So we deployed the underwater video in this area, monitoring the coral reef ecology, and so this website photo, you can see the real-time coral video data, and on the right of it is the sea level and the seawater temperature data. And if you access this website, ecocom.nchc.org.tw, so you can have the real-time underwater coral reef image. The following slide, I will talk about the coral spawning. So as I mentioned, this is the major recovery force for damaged coral reefs. And this slide shows the coral release the gametes. in southern Taiwan, based on our study, for the reproductive season from January to December, since March, there are some coral release their gametes, but in April and May, it's the major reproductive season. So in each of months, more than 40 species they release their gametes, and the reproductive activity will continue until October. So from March to October, some corals release their gametes, but mass spawning occurred in April and May. So it's the late spring and early summer season, and the northeast monsoon has been stopped, but the southwest monsoon and typhoon season still not occurred. So it's the best time, environmental condition for coral spawning and their offspring survive. And for the lunar cycle of coral spawning, from the lunar day 1, it's the new moon, to lunar day 15, it's the full moon. In Kenting, southern Taiwan, the coral release gametes after the full moon. Then more and more species reproduced and peaked around the lunar day 21 and 22nd, then decreased again. So the coral spawning peaked around the second quarter. That's the nip tide phase, because the nip tide water exchange is slow. So it's very good. It's better for the gametes fertilized and help for their survival. And for the dive cycle of coral spawning, many of the coral they release their gametes in the night. So the sunset occurred around 17 hours. Then from 19 hours, some coral started to release gametes and peaked around 8 and 9 o'clock in the night. So that's for the spawner species. They release gametes into the water and fertilized externally. The following slide, I will introduce the brooder species. So they release their larvae. So this tissue section photos shows the mature eggs inside the polyp, and after it fertilized, it will become the fertilized eggs will develop to the embryo, as another section photo shows. And this black and white photos is the infrared image. So we can use it to observe the larva release. As shown in this white spot, is the larva. So for study this larva release of corals, we use this outdoor flow-through system. So we apply the collection permit, then collect corals from the field, transport to our museum, then put into this flow-through system. So after the larvae was released, they dripped in the water and flow through into the collection cup. There is a plankton net there. So we count the larvae number later. So for these 5 species, Posilopora damicones, Ceratopora hystrix, Stylophora pistillata, they are very common species in Indo-Pacific. And Euphilia galabrescens and Tubastria aurea, these are very common brooder species in southern Taiwan. As you can see, their adult morphology, and on their right side is their larva morphology. So this larva, the length about 1 millimeter, and each one species they have different shape and the pattern of the distribution of rudensidae. So this slide shows the seasonality of larva release from February 2003 to January 2004. It's a whole year. So here shows the 3 species data, Posidopora damiconis. So you can find 12 peaks of the larva release in this fix. The similar pattern for Ceratopora hystrix. So for these 2 species, they release larvae throughout the year, and every month there is one lunar cycle of the larva release. They release larvae highly synchronized. So the larva release timing is very long throughout the year for this brooder species. And this figure shows the dial cycle of coral larva release. For these 5 species, actually they can divide it to 3 types of larva release. For the first 2 species, they are highly synchronized and release larvae only around the sunrise. And for the 3rd and 4th species, they release larvae throughout the day, but there are 2 peaks, one around the sunrise and one around the sunset. And for the 5th species, there is no spatial pattern. They release larvae throughout the day. So it shows the variable strategy of for the dial cycle of coral larva release. And if we look at the first species, the Ceratopora hystrix, on the right side shows the larva release timing and the relationship to the tidal cycle and the photo period. So you can see the larvae only released around the sunrise and not related to the tide cycle. And this slide shows some research on the regulating factor of dial cycle of larva release. So for Ceratopora hystrix, this species they release larvae highly synchronized around the sunrise, as shown on the controlled condition. Then, if you change the photo period, like if you use the constant light, the larva release will be inhibited. And then, if you turn off the light and get into the dark, they release larvae immediately. Or if you use the constant dark, it will inhibit the larva release. Then you provide the light and also get into the dark again. Then they release larvae around the sunrise. So it shows the photo period is a very important factor controlling the dial cycle of larva release. This is a very important finding. People can control the flowering time, and right now we can control the larva release timing of corals. And this is very useful for research because in southern Taiwan we can collect the larvae every month with hundreds of thousands of larvae. Then we can use this photo period to control when we get the larvae. So it became a very powerful research material for the coral larva ecology and physiology research. For some coral species, the larvae, when they are released, they have been matured and they settled very quickly. As shown in this slide, many of the larvae they settled on the substrate within 24 hours. and the lava released later, and they will settle earlier. For many people, they are very interested on the coral spawning event. It's a world-famous biological phenomena. But for coral reef biologists, especially for conservation, it's very important to know how much of the coral offspring come back to the natural reefs. So this is the coral recruitment. So we use this settlement tile deployed under the sea, and the larvae will settle on the tile. Then we collect the tile, examine under the microscope, then count the recruitment rate. We are very excited to find the coral recruitment rate is very high in southern Taiwan. As we showed in this slide, for the settlement tile deployed under the sea for 6 months in Nanwan Bay, the upwelling influenced area, the coral recruitment rate ranged from about 100 to about 400 recruits per square meter per year. For the settlement tile immersed for 2 months under the sea, the coral recruitment rate ranged from 1,200 to 1,300 recruits per square meter per year. Actually, this is almost the highest coral recruitment rate in the world, especially if you consider the coral reefs. The area is small and quite remoted from other reefs in southern Taiwan. So here I will summarize some important characters of the coral reefs in southern Taiwan, especially focused on the Hobihu reefs, because we have much more research data. So in the reefs here, they are well developed fringing coral reefs, and the coral diversity is very high. We have more than 300 stony coral species, and the coral abundance is also high. And here, the internal tide induced upwelling causes large temperature fluctuation, so it can rescue the corals under the abnormally warm. And here, absence of the outbreaks of the crown of thorns sea star and a few coral disease occurred here. And this area escaped from natural and anthropogenic disturbance. So based on these characters, we consider the resistance here it may be high. To evaluate the resilience, here located at the downstream of Crucial and the South China Sea surface current, so transport a lot of clean water and offspring to southern Taiwan. And as we show, corals have very long, protracted reproductive timing. And we have some studies shows the reproductive timing. They are flexible and adaptive to the environmental change. And coral recruitment here is very high. Some case shows the coral recovery is quick, like in the thermal outfall area of the power plant and the Tiaosi. And we have some laboratory study shows corals here, they are acclimatized to the warmer temperature and fluctuation temperature regions. So we consider the resilience may be high also. So with this high resistance and resilience, these coral reefs they are variable to be protected for the future. The following slides, I will introduce our National Museum of Marine Biology and Aquarium because now we have some unique coral reefs in the field. Right now, through the human efforts, we put a lot of effort to do the research and the education of coral reefs. Here shows our museum. So we have 3 pavilions of marine organisms exhibit. It's the water of Taiwan and the Coral Kingdom, and the waters of the world. Later we will go to the Coral Kingdom to look at our live coral exhibit. So this is for the public aquarium, and we located on the natural coral reefs. For the research and education, we have 3 buildings. They are husbandry. We cultured a lot of live corals there. It's the largest coral farm in the world. Later we also will visit there and to show you how to culture live corals. And we also have 2 buildings belonging to Institute of Marine Biodiversity and Evolution and the Institute of Marine Biotechnology. This slide shows our live coral exhibit at the entrance of Coral Kingdom. So this world-class and multiple function coral reef mesocousins, they can use as for exhibit, education, research, and conservation. As some scientists predict, the coral reefs in the field may be extinct around 2050. If corals cannot survive in the field, we can, through the human effort, to culture corals under the artificial environment. So these live coral tanks can act as the Noah's Ark for coral and reef organisms. We culture these corals through the natural reef aquarium. We learned from the nature, so we simulate similar habitat and typical marine organism in the tanks. So this live sand, live rocks, and the key functional group like the herbivorous fish and sea urchin snails. And also we use the sea cucumber to keep the live stem ecologically functional. We also culture a lot of live corals in the husbandry. So this mass culture of corals provide a lot of live corals material for research and education. Some corals actually right now they can live in the artificial environmental condition with complete life cycle. Like this brooder species like Posilopora damicones, they release larvae. Then we collect the larvae. The larvae settled on the tile and cultured under the artificial environment. Usually 2 to 3 years, they are sexually matured and they can release larvae again. These cultured corals also can be used as materials for transplantation and restoration of coral reefs in the field. So this slide shows the corals cultured in our museum, then transplanted in the field. This slide shows the bird view of our museum. Actually, this is one of the largest area, and for the coral reef education and conservation. So as I showed, we have 3 public aquarium, and we just located on the natural coral reefs. And right now, in our husbandry and aquarium, we captured about 130 coral species. Actually, we have about 50,000 coral colonies cultured here. And for our aquarium, every year more than 1 million visitors here. We have 26 PhDs as a scientist conduct research here. Every year we have 30 graduate students here. So if you are interested for coral research or get master degree, we are very welcome. These coral reef tanks, they can act as some powerful tools for education and research. As here, these coral reefs, they can act as a long-distance research and education of coral reefs. So in our live coral tanks, we can deploy the underwater video. They can be the high-definition video, so you can see very detailedly on the coral reef. So like the coral larva settlement and the growth of recruits, or the interaction between the plankton and the benthic organisms. Then through the HD video, this image can be showed in the virtual reality aquarium, like in our third pavilions, or you can see the real-time image at the website. So publics, through this system, the public they can seeing the invisible before. These coral reef tanks, they also can act as a controlled environment facility. So you can control the light intensity, the temperature, and the pH. So they are powerful tools to examine the effects of ocean warming and acidification on coral reef community. And through the monitoring and the sensor network, you can checking the changing of biological and the environmental factors. Through all of this effort, hopefully we can help to the sustainable development of coral reefs. Not only they can exist under the artificial environment, most importantly, they can exist in the field forever. Thank you very much.